Hi, I'm Ron Wilkie, your cyber security quarterback. Cyber security quarterback. Say that 3 times quickly. All right, so this particular video is dedicated to an email I received. And that email basically asked me how to understand the technology around a physical security network project. So the individual is a project manager and they want to understand the technology. So in their meetings, they can understand what's going on and actually communicate with the subject matter experts without looking crazy. And you know, as a project manager, sometimes you may not understand everything the subject matter expert understands, but you want to be of value. You want to understand. You don't have to ask a million questions. So this individual sent me an email and asked me to talk about physical security, how it relates to the TCP/IP. I guess they're doing some type of TCP/IP upgrade along with upgrading some of their infrastructure on the physical security aspect of their network. All right, so that's what we will talk about. My goal is to do this talk in less than 15 minutes. Physical security. I have to write it because I will get sidetracked. Project. Oh, and with that said, they did ask me about TCP, IP, and the relationship between physical security network and TCP, IP. And so basically, I think I'll start from the beginning. You have your different layers. You have your physical, your data layer, your network, transport, session, presentation, and application. You're like, wow, Ron, Mr. F5, you remembered all of that? That's pretty easy for me. I have set it up so that I remember this by the first letters. Please do not take sausage pizza away. That stands for physical data, network, transport, session, presentation, application. All right, so this is called the OSI model. This is old. Nobody really uses this anymore. That's old, antiquated. But most people use TCP IP. And so you have a layer called application. And this is basically how your information flows from one computer to the other. And that covers these 3 layers. Transport coincides with that transport layer. Network. This is called internetwork or internet working on the TCP/IP side. And these 2 layers together are network. So we are talking about the physical aspect of the security project on the network. So there are certain things you need to know about this layer right here. And this is what we will talk about. Later, I will talk about these other ones in future videos if someone wants to know a little bit more about these other layers. But for instance, let me just go ahead and talk about it really quickly while I'm here. You have your cables, physical things like your hubs, repeaters, and wireless. So that's what you have here. Network. I'm going to put physical network too, just so that we stay on point. With the network layer, internetworking, basically you have your IP. That's where the IP comes from when you say TCP/IP. ICMP, IGMP, and some other ones. Transport, basically this is your TCP of the TCP/IP part. This is the TCP and the UDP. And again, this is very technical, but you'll get it in the end. An application, basically FTP apps, HTTP. Now, what you see, you don't see me putting Internet Explorer or Chrome here. It's the HTTP aspect of it. SMTP, POP3. These are your emails. This is browser. This is file transfer. Application. Also, in this realm are your formats such as MP3 or MP4 if it's a video, JPEGs. So this is where you determine your format, and when your format goes from one system to the other system. And your session is basically your handshake from computer A to computer B. So I pretty much tried to break that down in a simple way. Your physical, cables, hubs, repeaters, wireless, internet working, IP, ICMP, IGMP. Now some of these acronyms, that's Internet Protocol, I will get into in other videos. Okay, so don't worry that you don't know about it here, because we're talking about the physical security network project, right? See, I wrote it at the top so I wouldn't forget. All right, let's go ahead. I'm gonna go to another page. All right, so the first thing you want to understand, and when you're building your requirements for a physical security networking project, you need to determine whether or not you're worried about analog or digital. So this individual stated that they are upgrading, so I'm assuming that they're going from maybe some analog aspects to digital. So for instance, an analog would be something like a photocopier. All right, but a digital file would be like that JPEG file or TIFF. Really, people don't use TIFF anymore as much because they are larger files, FYI. Let's say you have audio tapes. The digital conversion would be something like an MP3. I could do this all day. Let's say you have tapes for data. It could be considered digital, but a more recent format would be something like a flash drive. Or when I say tape, I guess I could be talking about punch cards. So instead of saying tapes, I'll say punch cards, even though that can still be that still can be considered digital to some people. I could do this all day. Your watch, hands on a watch, are that's considered analog, and numerical numbers would be digital. All right, so just to give you a little information there. Man, my time is almost up already. Good grief. All right, so let's talk about your cables. So you need to understand your bandwidth that you're working with as it relates to broadcasting information. Like for instance, is it unicast, multicast, or broadcast? All right, so you also need to worry about whether or not your cables are going to be with other cables because of electronic interference. So with that said, I'll go ahead and write it out. Please forgive my handwriting. Electronic interference. So if you are worried about that, you need a shielded twisted pair cable. Shielded because it shields the cable from noises, electronic noise, buzzes, interference, frequency interference. But if it's a standalone cable and you're just running it down the wall by itself, you can have an untwisted pair, and that's less expensive. Let's do the $sign. You also need to worry about what type of jacket your cable is in-housed. So basically you have Teflon and PVC. And it's good to know that PVC, when it's burning, it emits a deadly gas. So that's why, for the most, if you have an electrical fire, you definitely don't want to have your cable with a jacket that is PVC. So most of the time, obviously, we'll see Teflon, because the most important thing is saving lives. It's not your equipment, it's not your data, it's always saving lives. Let's see, what else do I want to say? You also have fiber optics, and I could do another video on fiber optics. All right, so I think that's pretty good for now. So let's talk about topologies. I'll go to the next screen because I think I will need the entire screen. You want to ask your team what type of topology are you working with, or do they propose? And this is probably why I'm doing this video. I probably should have started off with this. I made you wait 11 minutes just to get to this. Tree, mesh, bus, tree, mesh, star, and I'm missing one, ring. So a ring topology, you have your cable and you have your devices. Got servers, computers, other things. So this is the most secure. But it's not really scalable. So that's bad. But it's secure. Star, this is your star. So you got something like a hub here, or router or something, whatever. You got your systems here, here, and here. So that's pretty good, right? The problem with this, well, the good thing is that it is scalable, but you have a single point of failure. If this goes down, everything goes down. Also with this ring, it has a single point, SPF. If something happens here, the data will not go around to the other systems. So let's talk about something that doesn't have a single point of failure. Mesh. I'll just draw it like this. So the data it travels all around. There is no single point of failure. It's not really that scalable. It is, but it really isn't, because it is expensive. All right, so tree. This is a tree. You have something like this, something like that. This is scalable. But you have, if something happens here, this side of the network goes down, but you still have information here. So that's good. So sometimes it can be paired improperly. As it relates to your redundancy. And bus, you have your cable line, you have something here, something here, something there, something here. And so this is pretty good, but guess what? You have a single point of failure again. And if this doesn't work, they don't get their information. All right, so that's the basics of some type of physical security networking setup. One of those types, and then I just went over your cables, different types of cables, and going from analog and digital, and the different layers as it relates to TCP/IP and the OSI setup. Hope you got something from it. See you later. Send me an email. Let me know what you think and what you need.